Hey, this is Moiz from Mahida Academy. I am super excited that you are here and that you are spending some time with me today to improve your chemistry. So in this lesson, we will learn about solvent extraction. So what is solvent extraction? Solvent extraction is a separation technique. A separation technique is a method that separates a mixture or solution of chemical substances into two or more distinct components. The simplest example is filtration. Filtration technique is used to separate solids from a mixture of solid and liquid. It is the act of pouring a mixture onto a membrane, usually a filter paper, that allows the passage of liquid, which we call the filtrate, and results in the collection of the solid as residue. In solvent extraction, the solution under observation is placed in a separatory or separating funnel and shaken with an immiscible solvent. Immiscible liquids are those liquids that do not mix together. Oil and water are two liquids that are immiscible. The important apparatus used in solvent extraction is a separating funnel. It is also called a separatory funnel or a simple SEP funnel. We will discuss a little more about separating funnel and immiscible solvents in this section. In a separating funnel, the more dense liquid sinks and can be drained out through a valve away from the less dense liquid, which remains in the separatory funnel. The location, either the top or bottom layer of an extraction solvent, depends on the relative density. The more dense liquid forms the bottom layer, while less dense liquids form the top layer. As an example, the density of ether is 0.7 gram per cubic centimeter and the density of water is 1 gram per cubic centimeter. Therefore, ether will always form the top layer when the extraction solvent pair is ether and water. Likewise, density of carbon tetrachloride is 1.6 gram per cubic centimeter. Therefore, in carbon tetrachloride and water pair, carbon tetrachloride, being more dense, will form the bottom layer. Solvent extraction is a separation technique, as we discussed already, and it involves the distribution of an analyte between two immiscible liquids, usually a polar and a non-polar. An example is water, which is polar, and ether, a non-polar liquid. When a solution is placed in a separatory funnel and shaken with an immiscible solvent, dissolved substances transfer from one liquid into another liquid phase, generally from aqueous to organic. The components are said to partition between the two layers or distribute themselves between the two layers. This transfer is based on Nernst distribution or partition law. Hopefully, we will discuss the principle of solvent extraction and partition law in next lecture.